Welcome to Lesson 97 of Saxon Math Course 2. In this lesson we're going to talk about similar triangles and indirect measures. We're going to identify the corresponding angles and corresponding sides of similar triangles. We're going to use proportions to find the lengths of unknown sides of similar triangles, and then we're going to use proportions to measure the height of an object indirectly. This will be somewhat new. Well, it will be new to you, but I think it's a concept that you will grasp okay. All right, so as you well know, we often use tick marks to indicate congruent angles. So in this particular drawing here, we know that A and Z have the same angle because of the single tick mark, and we know that B and Y have the same angle also. So can we in this case conclude that C and X also have the same angle? Yes, we can, because we know that both of these have got to equal 180. And if these two are the same, then these two also have to equal the same, so they both equal 180. All right, so the lengths of corresponding sides of similar triangles are proportionate. So when these are the same, we know that this and this, these are the same, except for one may be bigger than the other. So that's what we're going to be dealing with. So let's look at this. This means that the ratios formed by corresponding sides are equal, as illustrated by these two triangles. So if we look at these, take the 6, and it's in the same spot as the 3. And the 8 corresponds with the 4, and the 10 corresponds with the 5. Well, we can see that if we divide all those down into it, they're all increasing. Right? 4 goes to 8 is 2, 5 goes to 10 is 2, 3 goes to 10 is 2. So this is 2 times bigger than this one here, or the other way around, the smaller one is 1/2 the size of the bigger one. All right? So let's see how we can do that when we don't have all the numbers. All right, so estimate the length of A. All right, so we're going to think of cross multiplying. All right, so in this particular circumstance, we're going to go ahead and look at the ones we do know. Okay, so we do know that 6 and 10 correspond. 6 corresponds with 10. So that's going to be equal with 3 corresponding with what? With A. With A. Now we're just going to cross multiply. That equals 30. And we're going to divide it by our 6, because we got to isolate our A. Because it's being multiplied, we're going to divide by 6 to get rid of it. So we know that A is going to equal 5. All right, get the idea? Not too bad. I think you can do this. All right, so now let's figure out using pictures and do some indirect measures. So Sarah's looking up. She says, "Hey, I wonder how tall that tree is." And Beth looks down and says, "It's about 25 feet." So Beth, she didn't pull out a tape measure it. Instead, she used indirect estimates to determine the height of the tree. And let's figure out how she did that. Well, we can separate the two of them. We can take Beth here, and we can line her up, and we can take the tree, and we can line it up, and we can assume that the sun up here is casting the shadow the same for both of them. And so they're similar triangles. All right, so if we know a little information about Beth and her shadow and the tree shadow, we should be able to determine the height of the tree. So what we're going to do is we're going to set up a ratio box. We got Beth and we've got the tree. We're going to put the height of both in here, and we put the shadow in both. So if we know that Beth is 5 feet tall and she casts a shadow that's 6 feet long, and the shadow of the tree is 30, then we can now determine the height of the tree. So if we take 30, 150, and we divide it by 6, then we know that the height of the tree is going to be about 25 feet. And that's how Beth knew how tall the tree was. All right, so let's try a couple of these. Okay, so to indirectly measure the height of a telephone pole on the playground, so I'm going to go ahead and draw my telephone pole here. All right, telephone pole on the playground. Some students measure the length of the shadow cast by the pole. The shadow measured 24 feet. 24 feet. And the length of the shadow cast by a vertical meter stick, so here's my meter stick, was 40, and it casts a shadow of 40. You also have to know that a yardstick, a meter stick, measures 100 centimeters in height. So now we have it set up, right? And here's our shadows, right, coming, and our shadows. So now we can set it up. We can set it up in such a way that we can cross multiply, and we can do it. So let's go ahead and make our box, right? And we have our height, and then we have our shadow. So here's let's go ahead and put in our meter stick here, and let's put in the pole right there. So we know that the pole, we don't know the height of the pole, but we do know the shadow was 24, and we know that the shadow of the meter stick was 40, and we know that the height of the meter stick was 100. So once we have that, then we can cross multiply, divide by the 40, and come up with our answer of 60 feet, and know that this was 60 feet tall. All right? Get the idea? It's just a matter of getting into the boxes correctly. Just remember height and the shadow, the length of the shadow. All right, so let's try one more. Let's see if we can do this one. So Brad saw that his shadow was the length of about one big step. So let's go ahead and draw Brad here. Here's Brad, right? All right, there's Brad, and he's got a shadow of 3 feet, which equals one big step. All right. Now, he then walks along the shadow of a nearby flagpole. Let's go ahead and get our flagpole up here, right? And found that that's going to be 8 big steps. Well, one step is equal to 3 feet, so 8 is going to be 8 times 3. So this is going to be 24 feet, right? We can do that in our mind because it's 8 big steps. And our answer is definitely not going to be in big steps. And if we know that Brad here is 5 feet tall, now we can figure out the height of the flagpole, right? So let's go ahead and we'll make our box. Let's find a spot for it. Let's go ahead and put it right here. All right, and we've got height, and we've got our shadow, and here we got Brad, and we have our flagpole. All right, so Brad we know is 5 feet tall and casts a shadow of 3 feet. And then the pole, we don't know how tall it is, but we know it casts a shadow of 24 feet. So now we can cross multiply this. So 24 times 5, that's 20, that's 120. 120 divided by 3 is going to be 40. So we know that our flagpole is 40 feet tall. Answer C. All right. Okay, I think you'll get it once you get the boxes down and you get everything in the right place. I think that this is math you're all very capable of doing. Thank you for watching it. There's your TIDs. Please submit those tonight. We'll see you tomorrow in class. Thank you.